Okay, guys, now let's see with the 7th MCQ here. Okay, let's see the question. Okay, 7th one. When 1 mole of gaseous XY is heated in a closed vessel at 750 K. Okay, always when you're doing the question, keep in mind, get the clues by drawing the diagram here. So, this is actually from physical chemistry, obviously. This obviously comes from the physical chemistry part. So, now there is a closed vessel. Now, there is a closed vessel. There is a closed vessel. So, the temperature of the system is around 750 K. No harm, 750 K. Now, when 1 mole of XY, so okay, already there was some amount of XY, that is actually 1 mole. So, XY gas was there, right? At 750 K, 50% of gas is dissociated at equilibrium according to the following equation. 50% of the gas has been dissociated when it is heated to 750 K. So, 2XY gas partially dissociates to give X2 gas and Y2 gas. See here, whenever you get an equilibrium reaction, you have to keep in mind, you are not going to get any limiting reagents here. Obviously, you are not going to get any kind of limiting reagent over here, right? Absolutely nothing. The only thing you have to know is what will happen once you heat the system, or once you cool the system. It's actually related to the Le-Chatelier principle. But see, in this question itself, they have said once they are heating it up, it dissociates. Which means the formed reaction might be endothermic, right? It is actually endothermic. That's why it dissociated. No, it has to be endothermic. That's not the case. Now they are asking us. The final question is like, what is the Kc for the equilibrium of 750 at 750 Kelvin? They are asking the Kc. They are asking Kc, yeah, means concentration constant, equilibrium constant Kc at 750 K. So this is the question. You know that Kc depends on only on the temperature. The equilibrium constant usually depends only on the temperature, not in any other factors. They can ask in the exam also. They have asked in the 2022 MCQ also, by doubling the volume, what will happen to the concentration constant, equilibrium constant, what will happen? So that nothing will change. It will change according to the temperature only. So Kc depends only on temperature. Okay. Now see here. Initially, right? Right? Now you have you had initial moles of 1 mole, right? You had 1 mole. Now they didn't give any specific volume here. So let's say I am taking the volume B. I am taking the volume B. So initially you don't have anything. During the reaction, 50% of XY is actually completely dissociated. So 50%. So 50% of the gas is dissociated at equilibrium. So these are equilibrium means 50% of 1 mole is actually 0.5, right? So it's like 1 into 50 over 100. Simple. Half, no. So what is the answer? Minus 50, right? Which means minus 50 over 100 means minus 0.5 moles is actually dissociated. 0.5 is actually dissociated. If minus 0.5 is dissociated, half of this has to be there in another case. Why? Because here you have 2, here stoichiometric ratio here is 1. This is 2:1 ratio. So if this is 0.5, half should be here. So how much? 0.25. Right? So I'll write it in this way. Plus 0.5 divided by 2. Here also plus 0.5 divided by 2. Some of you might have problems here, right? Do in this way. Never mind. If you get confusion here to find the stoichiometric ratio, do in this method as I do. So the number of moles of XY gas is to, you need to find for this. If you find for this, you can directly find how much is for this, because they both of them are in same stoichiometric ratio, no? 2:1, 2:1, so no harm. So NX2 gas is equal to, what's the stoichiometric ratio? 2:1, right? Take your time, do it quickly. So how many moles over there? XY you have 0.5. So NX2 is equal to 2/1. So how much moles of X2? NX2 is equal to 0.5 divided by 2. Practice. So if you are practicing a lot, you can do this thing in less than in seconds. Less than seconds you can get. It's very easy, right? This one's half. So what is the remaining? They are going to get minus, 0.5 mole. Here you are going to get plus 0.5 divided by 2. 0.5 divided by 2 moles are there, right? For Kc, you should keep in mind that you have to consider a thing, right? I have to consider a thing here. So Kc of a system is actually equal to, Kc is equal to the power of the stoichiometric ratio of the products over the power of stoichiometric products, stoichiometric power of stoichiometric ratio of the reactants. So here you have X2 gas to the power 1, their concentration, and here you have Y2 gas, their stoichiometric ratio as part of the 1, because you have 1 1, no, stoichiometric ratio is 1 1, and here you have XY gas, that is actually twice, by stoichiometric ratio is 2. Okay, so Kc is equal to, what's the moles we got? 0.5 over 2. So you have to do concentration here. So you know concentration is equal to moles over volume. I'll keep the volume here as V. So what is my volume here? 0.5 over 2 moles into 1 over V. Why? You are dividing now. So reciprocal will be there, so we get 1 over V. Same thing here, right? Into 0.5 divided by 2 moles into 1 over V. So if you totally divide by this, so you are going to get 0.5 whole thing square mole divided by V whole thing square. This 2 will come down, ne? This 2 will come down. So let me simplify you this equation, right? Let's simplify this equation. So Kc is equal to, so you can square them up. So you get 0.5 over V. Let's take the half outside, right? So this thing's whole thing square. This one's whole thing square. Why? I took the half outside. Two halves are there, no? So to the power 4, to the power 2, right? Divided by, I put this division over here, divided by 0.5 over V, the whole thing square. So you know, if you turn this division to multiplication, reciprocal, this thing will cancel out. This 0.5 will be cancelled out. So Kc is equal to 1 over 4. Kc is equal 1 over 4. The answer is going to be 0.25. Do we have any units? No. Why? Here you have mole decimeter minus 3. Mole decimeter minus 3. Here you have mole decimeter minus 3. The whole thing square. Here also going to have the square. Here also square. So therefore units will be cancelled out. So therefore you are going to get 0.25. So what's the answer? Fourth answer, right? So 0.25. So this is actually the fourth answer. This is the fourth answer for the question, right? Okay. Now let's see the 10th MCQ in the next video.